Welcome to another episode of Dominic Does DIY. This is part 2 of our H-bridge motor control series. The last time we went ahead and we looked at exactly how it is that we can control the H-bridge and what the PMOS and the NMOS do in order to control current. And on this episode, we're going to go through and see what do we use this information for. Why is it that we want a PWM? What information do we use in this? How do we make this usable in like real world applications? So as usual, like, subscribe, comment down below. So let's get into this of how we can actually learn how to use and put this motor design into practice. So why is it that we want to pulse the system? It is because we want to be able to control current going to the motor, because the current motor is torque, RPMs, things like that. So we're going to go ahead and change our runtime, and we're going to have a time on of 25 microseconds and a period of 50 microseconds. This will give us the 50 microsecond period is a 20 kilohertz pulse. So we'll run the motor at 20 kilohertz, and this will be about a 50% duty cycle. So you can see here, when we were fully on 100%, our current was about 15 amps. But now we're running about a 50% duty cycle at 20 kilohertz, and we've dropped down to about 6.3 amps. So now let's keep doing so we can create a graph. Right, what we'll do is we'll basically keep changing our period. We'll start and we'll make a chart of duty cycle from 0 to 100% duty cycle going backwards. So we know what 100% duty cycle is. It's 15 amps. So let's go ahead, do a 90% duty cycle. And you can see here, this is about 13.13 amps. Let's do an 80% duty cycle. And here we can see at an 80% duty cycle is about 11.1 amps. So I just went through all the percentages. And we can see here at the duty cycle of 100, we had 15 as we saw. At duty cycle 90, we had 13 as we saw. And then I just ran through all these other ones and got 11.1, 9.84, 7.8, 6.2. Then what I did is using the data sheet. From the data sheet, we can see our motor, the C34L80, and the W10, which is the A line from the graph, that everything is related to torque on here, right? So we have speed versus torque, and we have current versus torque. So what did we do? I took the current reading that we got, and I established my torque value at that current rating. So I would look at my current, my operating current versus torque. And then after I established, okay, this is how much torque I'm getting at the current, I would then establish, well, what was my RPM at that time? So then looking at the torque at this value, I would then see what was my operating speed at that time. So we can see from the graph that as our speed goes down, our torque goes up. And we can also see as our current goes up, our torque also goes up. So we can see here in the chart, as current goes up, as we go from 0 to 15 amps, our torque goes up. But we can also see that as our torque goes up, our speed, it goes down. So we have a no load speed on this motor, probably somewhere around the lines of 4,200 RPMs. And then when this thing goes under full load, will be at 263 RPMs. Why do I say that at full speed, at no load speed, will be at 42? Again, if we take a look at the motor spec, when we have no load, then we're not applying really any torque. The only torque comes on the internals of the motor. So we can see here that it's only the internal resistance, the internal torque is only 20 ounce inches. So that's pretty much nothing. So if we go back, so just figure it's going to be around here. Our speed is probably going to be max speed with no load on it. So of course, what do we use this information for on the motor? Well, usually we want to use a motor, we want to spin something. And sometimes we want to just spin the motor. Like if we want a high speed application like a fan, then maybe you don't want to put anything on the output and you just want to spin this really fast. But the other option is you want to actually do work. You want to put some output power, but your torque here isn't very strong. So you want to increase this torque. So what you do is you add a gearbox. And then we put the gearbox on. I'm just choosing a 10-to-1 gearbox. So with this gearbox, we can convert the speed into torque. So when we take the gearbox into account of 10-to-1, we'll take the speed and we will drop it by 10. But at the same time, we convert that the decrease in speed of 10 and we convert it into torque. So we can multiply our torque by 10. So we go from having a max torque output of 1125 ounce inches out to a gearbox with 59 foot-pounds of torque, or 11,250 ounce inches. But when it's pushing that much torque, it's also spinning really, really slow, right? And so I chose that 10-to-1 because like a no-load speed of about 400. And then you can decide at this point, well, how much torque do I really want to give them? Because this is where that PWM comes into play. So you might want to say, I've got 3 settings on this motor. I want it to run a high torque, a medium torque, and a low torque setting. So what does that ultimately mean with the electronics? Well, if you want to control the torque output, you want to control the current output, because we already know that our current dictates how much torque that we can get out. So then how do you control the current? Well, you use the duty cycle. If we adjust the duty cycle of the motor, then we can adjust the current. If we adjust the current, then we can adjust the torque. We want 3 torque settings. And we want one of those torque settings at 13 foot-pounds. We want another torque setting at about 24 foot-pounds. And then we want the final torque setting at, let's say, 43 foot-pounds. But then we want to shut down at 51 foot-pounds. Right? So this will be low, medium, high torque settings. And this will be shut down. Right? We don't want to overstress it, right? Because at that time our motor is getting bogged down, and so we don't want to go that far. So we just want to shut down at about 51. Then what does it mean, the 51? Well, the 51, what's the actual current at 51? Well, it's about 13 amps, right? So we know to get 13, to get our low torque, that's 30% duty cycle. And to get 24, that's going to be a 50% duty cycle. And to get 43, that's going to be an 80% duty cycle. But then our shutdown, how are we going to do the shutdown part? Well, that's going to be our current sense resistor, right? So if we look at our current sense resistor, that is 2.3 milliohms. So if we take our current sense resistor, and it is 2.3 milliohms, then what is our current at 51? Shutdown current Shutdown current, we're going to have that 51 is 13 amps, so 13 amps. Then shutdown voltage, that's just simply Ohm's law, V equals IR. So V equals 13 times our milliohms, 10 to the minus 3. So there we can see our shutdown voltage will be at 0.03 volts. Now, of course, this is probably impractical, so we'd have to go through this circuit and try to devise a better sense resistor in order to make this happen, because this is probably going to be too low. But that same microcontroller that you're using, you can have this going into an ADC, an AD converter. You can have this going into an ADC of a microcontroller, and then you can basically shut the motor out. So you're shooting the PWM out, you're shooting the PWM out, but then when the motor gets up to this certain level, let's say you just have full on and you just let them do whatever, you're no longer having a torque setting. So you're just letting them do whatever, have full on. So you also have, not only do you have a low, medium, high torque setting, but you can also have, so no setting, right? And you just let them whatever, so they can actually max this thing out. But instead of letting them max it out, you can limit them and say, well, I'm going to shut down at 13 amps. So you can have this going into the microcontroller, and then that way it would kill the motor from going after you reach that current level, so you don't damage any components. Thanks for watching another episode of Dominic Does DIY. I hope you enjoyed this episode and learned something about the motor control and the H-bridge. And as always, like, subscribe. If you have any questions, comments, or anything, let me know down below. Thank you.